Hi, my name is Bailey Warner, and this is my AB 205 Project 1. And for this project, I basically did four different types of, codes you could say. And I focused on a student who's looking at the differences or how productive their chemistry class was. And so, first of all, what the student would do if they were to come to this page, they would click enter the science course taken, into which you will then, through a user form, this will then pop up and you can enter chemistry 151 or chemistry 152. Those are the two options I gave them. So if I go to chem 152, I will say accept, okay, and save. And then it pops back down to cell A1. And then, so they'll determine what class they've taken. And then from there, they can then look at the general distribution of grades this past semester. And I hypothetically made only 35 students in the class because I didn't want all 300. But basically all I did was I did a randomization of numbers between the supposedly range of all the grades in chemistry 151 and 152. And then from there, I graphed my 152 distribution on as displayed to the left over here. And as you can see, it's very randomized because I used the randomized function. And just in case you wanted extra room on the Excel page, I made this an option to hide the graph or display the graph. And then what I did over to the right is I asked the student the question, did you learn these concepts? Which, although these are not technically concepts you learn in these two classes, they are generally science-based questions. And so we first asked about the Peaslet number, I think that's how you say it. And this is basically a dimensionless number that helps people with the study of transport and fluid flows. And to make it sound a little more or less confusing, I guess it's also defined as the quotient of the advective transportation rate over the diffusive transportation rate. So in order to determine this, we can enter in, if you have, say, a pipe of some sort, you can enter in the diameter of the pipe, say it's 12, the velocity of the flow through it, I'll say it's 3, the density, I'm going to say it's 5, specific heat is 1.3, and thermal conductivity is 100. And then the Peaslet number is right here, it says no units, and I will click this, and it'll pop up with what the answer is. And then that was just made through an if, then, and else statement. And then I have the BGen number, which is used in thermodynamics and fluid, I would say fluids, and which is basically the ratio of heat transfer irreversibility to the total irreversibility due to heat transfer. So what you basically do is, these cells need to be larger, but you have the length of the channel, which I'm going to say is 4, and I have pressure at 0.1, and pressure at 0.2. So if I'm going to make these different, I'll say there's a higher pressure going in than coming out. And then the momentum, I'm going to give it a 2, and then a dynamic viscosity is going to say 2.4. And then from there, I can then click this button, and your BGen number can then pop up on as through what do you call those? The boom. Yes, but it'll just basically pop up. And then finally, I asked the student if he learned simple temperature conversions, which hopefully they did actually learn in 151 or 152, which basically will convert Fahrenheit to Celsius, or you could even change from Celsius to Fahrenheit just by changing the letters in both cell N5 and P5. So if I were to say hypothetically that I have 30 degrees Fahrenheit, then I would just click temperature conversion, and it would then convert it to negative 1.1 degrees Celsius. And that's about it for my project. But overall, I did this project in order it was a science-based idea, and I wanted to display these three the temperature conversion, the p-slit number, and the Bijan number. And I just came up with the idea to just kind of have a chemistry student look at these different things to determine if they learned them or not. But that's it. Thank you.